Okay, so once again, I listed the 5 different congruent statements that we learned down at the bottom. So let's go ahead and look at the first one. It says A, B, C's. Remember that you have to have it in correct order, so it's going to be congruent to, see, R matches up with A, R. B matches up with W, and C matches up with I, and I see that this is side, angle, side, so I'm going to call it side, angle, side here. All right, next one, this one I can already tell that it's going to be angle, angle, side, because I've got 2 angles on the side. So angle A corresponds to E, B corresponds to S, and C corresponds to H. This one, because I have 3 sides, this is side, side, side. Angle A corresponds to G. B corresponds, I see B is in between 2 and 3, so 2 and 3 is N. And C is in between 1 and 2, which is T. All right, next, I see angle, side, angle. G corresponds to A. It's unlabeled, unlabeled. H corresponds to R. And J corresponds to E. All right, this one again, I have an angle on the side. So it's going to be A, S. C, let's see, angle A corresponds to D. B corresponds to S. And C corresponds to T. And then number 6, I have side angle side. None of these were right triangles, and so therefore none of them use HL, which is interesting. Okay, so A corresponds to H. B corresponds to E. Which would make Y correspond to C. Okay. All right, let's practice a proof. Use a concurrence statement or hot and tub. Let's see, hold on 1 second. All right, so first we're going to label these triangles, and I'm going to call this H. And I'm going to have to call this one T. O. U. T, and B. That should do it. Okay. Then it says, show the proper corresponding sides. So, I mean, H is congruent to angle T. Angle O is congruent to angle U. Angle T is congruent to angle B. So as you can see, I lined up all the congruent angles and the congruent sides. I listed them all. I guess I could also do this. O and U, and then 1, 2, 3. And then I could do H, O, and T, U. O, T, U. 1, 2, 3, 1, 2, 3, like that. So they're marked up and everything. Okay, equilateral triangles are always. Excuse me. Equilateral triangles are sometimes. I was thinking equilateral triangles always have 60-degree angles, but their side lengths might be different. So this is sometimes. Again, isosceles triangles are sometimes. The sum of interior angles is always. In a triangle, the image will always, whenever you translate, your images are always congruent. The only one where they're not congruent is when you dilate. Okay, so once again, I'm going to translate this. This is a review of the last test. So I'm translating to the right and down. The negative number is down and positive is through to the right. So I'm going to do that, translate the image, and okay, so I'm going to go over 3 and down 7. I'm labeling this F prime over 3. This is D prime. And the question is, are they congruent? And the answer is yes. And there's several ways you could do it, but I'm just going to say that this side is still equal to this side is still equal to this side, and this side is equal to this side. So I'm just going to say yes by side, side, side. All right, given xy is congruent to zy, so I'm going to mark that up. And w is a midpoint of xz. So midpoint definition here, these are congruent. Or got two congruent angles as well. Explain why these are congruent. Well, don't forget about this using the reflex property because you can't do ASS. Remember, don't be a donkey. So you can't do the ASS, so I'm going to have to use the reflexive property. So I'll just do a 2-column proof. Here's my statement. And here are my reasons. So my first is that xy equals zy, that's given. And w is midpoint. That's also given. So that's my first statement. My second statement is that wx equals or is congruent to wz. And that reason is definition of midpoint. My third statement is that wy equals wy. That, of course, is the reflexive property. And then my fourth statement is that these two triangles are congruent. Triangle XWY is congruent to triangle ZWY, and that is because of side, side, side. All right, here's another proof that I need to complete. So the first thing that I'm going to write in is, of course, that the givens. So we've got QR is parallel to PS. So if I extend this out, go to this here, I can see that this angle is going to be congruent to this angle. All right, and QP is perpendicular to PS, and RF is perpendicular to QR. All right, so I can say that angle QPS and angle QRS equal 90 degrees. That would be my definition. And then I can say that these two angles are congruent because all right angles are congruent. For number 4, I can say that SQR is congruent to angle QSP because they're alternate interior angles. And then QS equals QS, this part right here, because of reflexive. So therefore, they're both congruent because of angle and side. Angle, side. Very good. If this is difficult for you, you need to practice K, K2, K4, K5. You can even do K11. That would also be helpful. All right, so which postulate or theorem justifies that these are congruent? So let's first of all mark up. So A equals E. And A, B, and E, D have already been marked, and then this looks like a bow tie. So I know I'm going to be using vertical angles. So it looks like angle, angle, side. Below is a picture of a roof support. Ooh, this is going to be fun. It's going to be like when you go around the room. All right, so DEC is an equilateral triangle. So this, and this are all 60. Of course, it's not asking for that. ADG is an equilateral triangle. So these two sides are congruent. This angle is congruent to this angle. BDF, this whole angle here, is 120 degrees. DCB is congruent to DEF. Well, yeah, they're 90 degree angles. Okay, find the following measures. All right, find the measure of angle A. All right, I'm going to start here. I know this is 60. This is 90, so this one has to be 30. Okay. What else can I say? This is also 30. This is 60. And these are going to have to add up to 120. So let's see, 120 minus 60 is 60. So that means this one's 30. This one's 30. So if I look at the big triangle, because 30 plus 60 plus 30 is 120. So if I look at the big triangle now, that's 120. So I could do 180 minus 120, which is 60. And then this is going to have to be divided among this angle and this angle. So this one's 30 degrees. This one's also 30 degrees. So the measure of angle A is 30. A, B, C is going to have to be 120, because if this one's 30 and this one's 30, what's left here is 120. There's 180 minus 60, that's 120. Okay. CBD, well, this is 90 and 30. So 90 plus 30, that's 120. So that was 60. CDE, I know is 60. ACB, I know is 30. DEC, this one's also 60 because of an equilateral. And then we got BDC, that one's 30. And ECD, that one's 60. So there you have it. Using what you know about triangles to find all the missing information. Once again, go on IXL, practice the problems on IXL, and really go over this review sheet. Go back and keep trying the problems over and over and over again so you know the process. Because the process is going to be exactly the same on the test. It's just going to be different numbers. All right, let me know if you have any questions.